Good morning. Again, I apologize for not being able to be with you, but I am on jury duty still. So today we're going to look at segments and how they apply to number lines. And before we jump into any of that, let me just talk real quickly about a pretty simple case. Let's say that you are an avid football fan and you're watching your favorite team and they win the game 31 to 17. So 31 to 17. And the question becomes, well, how much did they win by? Well, you would take 31 and you would subtract 17, and that ends up being 14. 14 is how far apart the two teams' scores are. And you're like, what does that have to do with math other than the fact that I'm subtracting? Well, it turns out that if you're on a number line, you can find the distance between any 2 points by doing exactly the same thing. The distance between any 2 points on a number line is the difference, that means subtract, of the two coordinates. So the distance is also called the length of the segment with those endpoints. Oh, so it has to do with segments as well. So on this number line, the distance between point A and point B is, well, B is at 8, A is at 3, and that's 5. Now, some of you would say, well, I could just count that. And absolutely, you could. That's 1, 2, 3, 4, 5, not 4 again, 5 steps. And if it's close enough to each other on a number line, counting is just fine. Now, here's the problem with just counting. Actually, there are several. One is, what if you miscount? If all you write down for your answer for this is 5 because you just counted it, and it's wrong, if you miscounted, there's 0 partial credit. There's nothing I can do to give you any credit for that problem. The other problem is, what if they're further apart than that, where it's not easy to count them? We'll do an example like that in a couple of minutes. So what I would suggest that you do is take the larger coordinate and subtract the smaller coordinate to get the distance between the two. Now, on this, we also can say then that the length of segment AB is 5. So the segment that goes from A to B, I'm going to draw it just slightly above the line so you can see it, has a length of 5. How do we write that? Well, what textbooks do is they write it this way. Just AB equals 5. That means the length of AB is equal to 5, or the distance from A to B is 5. Some textbooks write it this way. They write a little m, and then segment AB is 5. That's saying the measure of segment AB is 5. We will use this one almost exclusively, but if you want to use this, that is okay with me. I kind of like this one better because it's like, oh yeah, it's segment AB and I'm finding the measure of it. As opposed to this one where there's no symbol above it at all. It is absolutely incorrect to write this. Segment AB is an object. It is a collection of points. It is not equal to anything. Its length, however, or the distance between its endpoints, is equal to something. The length of segment AB, or the distance between point A and point B, is 5. But you cannot, under any circumstances, write this. All right. Let's do some examples. Here on this number line, I've indicated several points, and we're going to find the lengths. So for AB, A is at -6, B is at -1. We're always going to take the larger one minus the smaller one. So the larger one is going to be the one that's further to the right on the number line, and then the smaller one will be the one that's further to the left. So for the length of AB, we'll start with A, which is at -1, minus -6. This is why we talked about adding and subtracting signed numbers. Minus a -6 is the same thing as +6. A -1 plus 6, we're adding two things that are working against each other. We're going to take the difference between them, which is 5, and keep the sign of the bigger number, so that's going to be 5. So for BC, the one further to the right is C, which has a coordinate of 3, minus B, which still has a coordinate of -1. By the way, I much prefer that you put parentheses around here, because this minus negative, it can, if you're writing real fast, it can be like that, which may be interpreted as just one big negative, so be careful of that. So this is 3 plus 1 is 4. For the length of segment DC, D is further to the right, and its coordinate is 7, minus the coordinate of C is 3. That's a nice easy one. That is just 4. So the length of segment DC, or the distance from D to C, is 4. And then the last one on this set, the length of segment CA. C's coordinate is 3. A's coordinate is -6. Again, we always do the right one minus the left one because we're going to do the bigger coordinate minus the lesser coordinate. We'll rewrite that as 3 plus 6, and that's equal to 9. And again, yes, I know that you could count these, but by showing your work on this, you will get partial credit if you do something wrong. If you simply count them and report that, that is okay, because it is something that's fairly easy to do. But if you miscount, it's all wrong. There is no partial credit. But let's look at one where that wouldn't work so well. If the coordinate of J is 47 and the coordinate of S is -74, find the length of segment JS. When you see this with no symbol above it, it means the length of that segment. So the length of segment JS, or the distance from J to S, we're going to take the greater coordinate, 47, minus the lesser coordinate, -74. So that's going to be 47 plus 74. You may want to come over here someplace and write what it is that you're doing. That's 11, carry the 1, that's 11 plus another 1 is 12. The distance between those two is 121. Which, if you think about it, makes sense. If this is 0, we've got a coordinate here, J, that's at 47, and a coordinate here, S, that's at -74. The distance from -74 to 0 is 74. And from 0 to 47 is 47. If we add those two distances together, we get 121. Okay, so that's segments on a number line for finding their distances. Now, what happens if we find that two segments have the same length? Well, if two segments have exactly the same length, we call those congruent segments. Some people say congruent. I say congruent. I think if you look in the dictionary, both are acceptable. But congruent segments are segments with the same length. So here I've drawn two segments, AB and XY. And we say if the length of AB, remember with no bar above it, that means the length of AB, or the distance from A to B, is equal to the length of segment XY, then segment AB, and this is a new symbol for you. It is read is congruent to. Segment AB is congruent to segment XY. Notice there's some subtle differences. Lengths are equal. So these two lengths or these two measures are equal. Here we're talking about the physical object. Objects are congruent. So when you're talking about the physical object, this set of points, we'll say they're congruent. When you're talking about their lengths, we will say they are equal. And the idea of congruent is going to come up a lot in this class for all kinds of different figures. And the idea is pretty simple. I want you to put down your pencil for just a second and do a quick experiment. Put your hands together, palm to palm. And then turn it so that you can only see one, either your right or your left. And it's not perfectly true for anybody because no one's hands are perfectly symmetrical, but one hand pretty much exactly covers the other. That's the idea behind two objects that are congruent. They're the same size and the same shape. Objects that are congruent are the same size and the same shape. So if you were to compare your hand palm to palm with someone else, it's unlikely, unless you have a twin that's identical to you, that your hands would be congruent. To be congruent, two objects have to be both the same size and the same shape. And that's part of why I like this symbol. The squiggle part reminds me that they're the same shape, and the equal part reminds me that they're the same size. So I think of this as a two-part symbol. Same shape, same size. We'll be using this symbol throughout pretty much the entire year. All right, the midpoint of a segment is the point. Notice it says the point. There's only one midpoint for a segment that divides the segment into two congruent segments. Oh, let me back up for just a second. I apologize. I forgot to do something. You may have noticed this little slash mark across both of these. This is the way that we will mark that two segments are congruent to one another. So instead of having to write all this out to show somebody on a diagram, we can just little slash, everyone knows that means that those two are congruent. It's not a huge deal right now because we're only going to be working with a few segments at a time, but a little bit later in the year we'll be working with multiple segments at the same time, and some of them will be congruent to each other and some of them will not. So it's important to have them marked. So I apologize. Let me go back to midpoint. The midpoint of a segment is the point that divides the segment into two congruent segments. So if I start with segment RT, there's going to be some point that divides this exactly into two congruent segments. Students will frequently say it divides it in half, which is true, but it's not what the definition says. The definition says that a midpoint is the point that divides this segment into two congruent segments. So here we know that S is the midpoint of segment RT. S is the point that divides segment RT into two congruent segments. And that's the way we would mark it on a diagram. Now everyone knows, oh, segment RS is congruent to segment ST because of that marking. So segment RS is congruent, remember that's our symbol for is congruent to segment ST. All right, well, let's talk about how midpoints apply to number lines then. So on a number line, the midpoint should be half the distance between its two endpoints. And there's an easy way to find that. You could count it and divide by 2 and do all this other kind of stuff, but the easiest thing to do usually is this. To find the coordinate of the midpoint, it's equal to the average of the coordinates of the endpoints. So if I'm talking about segment AB, halfway between them, I could count all the way, cut it in half, and then count from one side or the other. But, especially if it's not on a number line, an easier way is simply to average the two endpoints. So the midpoint is equal to the average of the two endpoints, or half of endpoint 1 plus endpoint 2. So, in this example, the midpoint of segment AB is going to be equal to half of 1 plus 9. So that's half of 10, which is 5. I would suggest that every time you work a problem with midpoints and endpoints for a segment, that you write this formula. If you'll do that, then you'll memorize it pretty quickly. Try not to look back at it every time. Try and make yourself remember what it is rather than just copying it. Sometimes your brain doesn't fully engage when you just copy it over. So, let's do two different types of problems with this. So if h has a coordinate -12 and r has a coordinate 7, find the coordinate of the midpoint of hr. Now, a diagram is not required on this at all, but it doesn't hurt. So I'm going to draw, and I'm not going to draw all the points between it. Oops. The coordinate of h is -12. The coordinate of r is 7. And I want to know what is the midpoint. All right. So I know that the midpoint is half of endpoint 1 plus endpoint 2. So the midpoint of segment HR is going to be equal to half of -12 plus 7. -12 plus 7, they have opposite signs. So we're going to take the difference between them, which is 5, and take the sign of the larger number, which is negative. That's going to be half of -5, which is -2.5. So that's what we'll do if they give us both of the endpoints and ask us for the midpoint. This next question, and this kind of thing happens in geometry all the time, is going to turn that around on us. Let's look at this next one. It says if A is the midpoint of segment CD, C has a coordinate 6, and A has a coordinate -14, find the coordinate of D. It's not asking us to find the midpoint this time. So A is the midpoint of some segment CD, so I'm going to put A kind of in the middle. Last time I put the letter on top. I'll be consistent. It doesn't really matter. It tells me C has a coordinate of 6, so it's got to be over here. And A has a coordinate of -14. We want to find the coordinate of D. There are several ways you can do this. I think the most straightforward way is to use the formula that we have for the midpoint and a little bit of algebra. So we know that the midpoint is equal to half of endpoint 1 plus endpoint 2? Well, we know the coordinate for the midpoint, so I'm just going to fill that in. It's negative 14 is equal to half of one endpoint, that's supposed to be a 6, is 6, plus I don't know the coordinate of the other endpoint, so I'm going to call it D because that's the endpoint that I'm looking for. From here, there are two different ways you can go. I'm going to show you both. One way would be to distribute the 1/2. It's not usually the way I do it, but it's okay if that's the way you do it. It would be negative 14 equals 1/2 times 6 is 3, plus, you have to multiply the half times the D also, so plus half of D. Now it's just solving the algebra problem. So I'll subtract 3 from both sides. I'll have negative 17 is equal to half of D. To get rid of the 1/2, I need to multiply by its reciprocal. The reciprocal of 1/2 is 2. And if I do something to one side of the equation, I have to be fair and do it to the other side also. This is be negative 34 is equal to, and 2 times half of D is just D. So that's one way that you can do this. You can distribute the 1/2. The other way that you can do this is start with the equation that we had, negative 14 is equal to half of 6 plus D. And I need to get rid of this half eventually. You can get rid of the half immediately by multiplying both sides of the equation by 2. 2 times negative 14 is negative 28. And 2 times a half is 1. So we just have 1 times 6 plus D, which is just 6 plus D. Subtract the 6 from both sides, and we have negative 34 is equal to D. One of the things that I love about geometry is frequently there's more than one right way to do it. So in either case, the coordinate of D is negative 34. All right, if you still have time left in class, please go ahead and get started on your assignment and get that turned in as soon as you have finished it. Hope you guys have a great day.